Having exported our substance graphs from Designer as both V-Ray-centric spec gloss and as default metal rough bitmap files, time in this exercise to put them all to work and see if the final render we get from them in any way differs from the substance version of the material that we worked with in the previous chapter. Inside of 3ds Max then, let's open up the material editor, and in the Wall tab, select all of the nodes in the existing V-Ray material tree, so not the physical material, and then after holding down the Shift key, left-click and drag to create copies of them all. Once done, we can select and right-click on just the V-Ray material node itself, and then use the Move Tree to View command to send these copies to the Wall EXRs tab. Jumping into that tab, the next thing we will need to do is delete all of the substance-related nodes that we have, so the substance and output map selectors, after which we can load in the EXR file that we exported for the diffuse channel. Now, straight away, if I just double-click to enlarge the thumbnail, you will notice that, as with the substance archive in the previous chapter, our half-float EXR file comes in with that gamma lightning applied to it. To make certain that we are able to, first of all, match our material to what we saw in the Substance Designer viewport and also to our renders from the previous chapter, let's plug our bitmap into the color map that we have sitting in the MOS chain, after which we will want to apply our material to the wall geometry, and then turn on the Show Shaded Material in Viewport option. Of course, as we are now using bitmaps in 3ds Max, rather than using the color map node as we have here, we could, at the point of loading the EXR file, switch Max's gamma controls from automatic to an override value of 1, which would have given us exactly the same result as we are seeing here. Which workflow we choose is really just a matter of preference, although using the color map approach does give us the option to easily tweak our gamma settings should we want to further on down the line. We will of course want to bring in the rest of our maps here, and so let's make 5 copies of the bitmap loader by holding down the Shift key as we left click and drag, and then we can add the relevant maps to those nodes, so reflection, normal, glossiness, IOR, and then finally height, after which we will want to connect them up to the relevant inputs on the V-Ray material. After checking that we once again have a dgamma color map node attached to the reflection map, and a V-Ray normal map connected to the normal chain for the bump slot, we can go ahead and take a render. What we get from that, if we just compare to our earlier V-Ray material render, so not the last physical material version of course, are some slight changes or shifts in the bump and displacement details, as well as some slight shifts in the reflectivity and colour levels, presumably due to the fact that we are now rendering with 16-bit files, as opposed that is to the 8-bit substance file that we were using earlier. In essence then, using floating point files out of Substance Designer is much like using the Substance Archive itself, seeing as we get a pretty straightforward plug-and-play scenario that again needs a dgamma node adding to the diffuse and reflection channels, whilst everything else can stay as is. Of course, what we don't get with bitmaps is the ability to change the parameters of the material on the fly, which we could very easily do when working with a Substance file. What though about the 8-bit files that we also output from Designer? Is the workflow going to be the same there, or again are there extra steps that we will need to think about? Questions that we will hopefully be able to answer in the next exercise.